Imagine for a moment that everything you rely on in your daily life, your power, communication systems, GPS, suddenly stops. No phones, no internet, no electricity. All of these things are vital to modern life, and we take them for granted. But what if I told you that something as simple as the sun could potentially cause all of that to disappear in an instant? It sounds like science fiction, doesn't it? But it's very real, and the events that could lead to such a catastrophic event are happening right now. Thanks to NASA's Solar Dynamics Observatory, SDO, we are able to watch the sun's behavior in ways we never could before, and with it, we are learning how to prepare for the powerful storms that it sends our way. The SDO offers the deepest and clearest view of the sun we've ever had, providing us with information that could one day protect us from catastrophic solar storms. Through the latest filter technologies, we can witness the sun in unprecedented detail. Solar flares, coronal mass ejections, and sunspots, the violent eruptions on the surface of our star, are no longer distant mysteries. With every ejection, with every pulse of solar wind, we gain deeper insights into the behavior of the sun and how it affects us on Earth. And that's not just important for curiosity's sake, it's vital to our survival. It's easy to forget just how powerful the sun really is. It gives us life, it's the source of warmth, light, and energy, but it can also be dangerous. These storms are capable of shutting down entire power grids, disrupting communication networks, and even impacting navigation systems. The SDO was designed not only to study these phenomena but also to protect us from their most destructive effects. And the stakes couldn't be higher. A solar storm, if large enough, could paralyze modern civilization in a matter of minutes. Can you imagine a world where the lights go out, planes can't fly, and your GPS is no longer functional? It's more than a bad day, it could be the collapse of everything we depend on. It might sound like something out of a disaster movie, but the sun has always been a force of both wonder and danger. For centuries, our ancestors revered the sun as a powerful deity. Almost every culture had its own sun god, a symbol of life, warmth, and strength. Today, we no longer worship the sun as a divine being, but we still depend on its energy. Without it, life on Earth wouldn't be possible. Yet, despite our dependence on it, we are vulnerable to its more violent outbursts. The very thing that makes life on Earth possible also has the potential to destroy the technological infrastructure that we've built. As a star, our sun isn't particularly massive or hot compared to others in the universe, but it plays a crucial role in our survival. Through a process called nuclear fusion, hydrogen atoms in the sun's core fuse together to form helium, releasing immense amounts of energy in the process. This energy radiates outward from the sun's core, passing through its various layers, and ultimately reaches Earth as light and heat. When you feel the warmth of the sun on your skin, the light that caused that warmth has traveled over 150 million kilometers from the sun's surface to reach you, taking about 8 minutes and 20 seconds to get here. That journey is a reminder of just how vast our universe is and how far this energy must travel to sustain life. But it's not just the warmth of the sun that affects us, it's the solar radiation, the electromagnetic energy that the sun sends out in all directions. This energy reaches Earth in the form of visible light, ultraviolet light, and X-rays. Our planet's atmosphere and magnetic field protect us from most of the harmful effects of solar radiation, but when the sun experiences intense activity, like solar flares or coronal mass ejections, CMEs, that protective barrier can be overwhelmed, potentially causing massive disruptions on Earth. When this happens, communication networks can go down, satellites can be damaged, and even the very power that keeps our homes and businesses running can be knocked out. We've already seen evidence of the dangers posed by solar activity. Back in 1859, during an event known as the Carrington Event, the sun unleashed a massive solar storm that caused telegraph systems across the world to fail. In some cases, telegraph machines continued to operate even without power, simply because the solar radiation induced enough electrical current to make them work. Sparks flew from telegraph wires, and in some places, fires were even ignited. Imagine the chaos if a similar event occurred today, but with our reliance on technology being far greater than it was in the 19th century. That's why scientists are so focused on studying the sun and its activity. The last major event of this scale was more than 150 years ago, but we could be on the brink of another one. The SDO was launched in 2010 with one goal in mind: to help us understand the sun in unprecedented detail. The observatory uses a suite of instruments to capture high-resolution images of the sun in various wavelengths, including ultraviolet light, extreme ultraviolet, and X-rays. These wavelengths are invisible to the human eye but reveal so much about the sun's behavior. The SDO's Atmospheric Imaging Assembly, AIA, captures detailed images of the sun's atmosphere, while the Helioseismic and Magnetic Imager, HMI, studies the sun's magnetic field. These instruments allow scientists to detect even the smallest changes on the sun's surface and track the development of solar storms in real time. It's not just about understanding the sun's activity, it's also about protecting ourselves from its potential dangers. The SDO, along with other instruments like the Parker Solar Probe, is helping researchers better understand how solar storms form, how they travel through space, and how they can impact Earth. The Parker Solar Probe, launched in 2018, is the fastest spacecraft ever built, and it's traveling closer to the sun than any spacecraft before it. This allows scientists to study the sun's corona, its outer atmosphere, up close and learn more about how solar storms are triggered. Meanwhile, the SDO continuously monitors the sun's activity, alerting us to any potentially dangerous events before they reach Earth. One of the most dangerous phenomena associated with solar activity is ultraviolet radiation. While we're all familiar with the sun's visible light, much of the sun's radiation is in the form of UV light, which is invisible to the human eye. Ultraviolet radiation is responsible for sunburns, and it can also damage our skin and eyes. But the UV radiation from solar storms is far more intense, and when the sun is particularly active, it can penetrate deeper into Earth's atmosphere. The SDO uses 4 different telescopes to capture images of the sun in various ultraviolet wavelengths, providing us with vital information about how solar radiation is affecting our planet. The sun's influence extends beyond just the visible light that warms us; it affects the very systems that allow our modern world to function. Solar storms can disrupt radio communications, GPS systems, and even the power grid. And as we venture further into space, these solar storms could pose a significant threat to astronauts, spacecraft, and space missions. If we are to send humans to the Moon, Mars, and beyond, we need to understand the sun's behavior and develop ways to protect our technology and our astronauts from its effects. But the good news is that we're not entirely helpless. Early warning systems like NOAA's Space Weather Prediction Center are already monitoring solar activity and issuing warnings for solar flares that could disrupt communications or power systems. When a solar flare or coronal mass ejection is detected, energy companies, airlines, and even military organizations are notified, giving them time to prepare for potential disruptions. But these warnings are only useful if we have the right systems in place to protect our infrastructure. Researchers are already working on developing better shielding for satellites, power grids, and communication systems to make them more resilient to solar radiation. The sun's power is awe-inspiring and terrifying in equal measure. We've seen the damage it can cause in the past, and we know that we're vulnerable to its whims. But with the advancements in space technology and our growing understanding of the sun's behavior, we are better equipped than ever to protect ourselves from its more destructive outbursts. The SDO plays a critical role in this effort, giving us the knowledge we need to keep our world running smoothly, even when the sun is at its most unpredictable. So, the next time you step outside and feel the warmth of the sun on your face, remember that you're not just basking in light, you're witnessing the power of a star that holds the fate of our world in its fiery grasp.